Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2019, Time Zone 1 in May. Question number 21, relating to a higher level topic, topic 16, the kinetics, particularly the understanding of the rate equation and also the reaction mechanism. They're asking, which is correct for the reaction mechanism shown. So given to you now the reaction mechanism. So 3 of the intermediate steps and telling you a really important information. So that is the first step is going to be the slow step. And remember, from the first thing that after observing this given situation, students should have recognized that, remember, the slowest intermediate step across the entire mechanism is also said to be the rate determining step. Rate determining step, or simply say RDS. Yeah, the rate determining step is the most important step across the entire reaction mechanism because the slowest step, the RDS, is the one that judge the rate equation, and that is the one that we will put in terms of the rate equation and also the ingredients and also the coefficients, which is going to be the rate order corresponding to or with respect to its reactant. So in this case, according to the understanding, the slow step goes to this one, and so the reactant, which is going to be 2A, so that means a bimolecular rate determining step. 2 molecules are involved in this reactant side, so that's why we should notice that the rate in this case should be equals to the rate constant times the concentration of A to the power 2. The 2 come from the coefficient, and the A is the reactant that we're concerning, according to the rate determining step. Mind you that only we can deduce this concept out when given the reaction mechanism, and from the mechanism we search for the slowest step. So this perfectly explains why we should never observing the overall equation and do this deduction. No, but only do such a deduction from the rate determining step. So that means obviously the rate equation should be something relating to A square. So that's why answer is now limited to A and D, right? And let's look at the overall equation, the overall reaction. Not so difficult. Overall reaction is formed by combining all the individual intermediate steps, right? So that's meaningful. That makes sense because all the steps after combining will then be forming back the overall pathway, and the overall pathway will set to be the overall reaction, right? So just a simple math, just treat the arrow sign to be just like equal sign, and imagine now I'm having 3 simultaneous equations that I want to add them all up. So that's how we add up the left sides all add up, right hand sides all add up, right? And then eventually, if there's some common factors, that we can simply delete them, right? So for example, in this case, we can see one of the B is on the right hand side that can delete with one of the B on the left hand side. Similarly, we have 2 of the C's on the right hand side that can delete with both the C's on the left hand side, right? And also for D as well, right? We see 1 D on the right and 1 D on the left. Finally, for E, both on right cannot be deleted but add up, and also 1 of the F finally remains and 2 of the A remain. So that's why the remaining thing, which is going to be 2A, goes to 2E plus 1 of the F, right? So this is the overall equation, right? So overall equation is having the reactant, right? A. So that's why this reactant can be present on the rate equation. So it makes sense. So after double checking, so that's why the answer will then be going to, sorry, not this, but this, 2E and F, 2E and F. So that's why the answer is going to be D.